Okay, here we will talk about the basics of air conditioning. Okay, so this is the air conditioning journal. Okay, like from ISRE Mumbai chapter or whatever it is, right? So this is the one of the journal I received. Okay, this information is available in LinkedIn. Everyone used to share many document. Okay, but here we will go through that what is important, which is required for our calculation purpose. Okay, if you go down, you know that there are comfort air conditioning, then there are process air conditioning, right? Then if you go into the inside the space, okay, there are human people, there is a room, okay, inside there are a lot of heats, okay. So we are going to maintain the comfort level, correct? So you can see that there are heat from radiation and convection, conduction, right? And if you talk about convection, when the body is rejecting the heat, okay, the air closer to the body becomes warmer than the air which is away from the body. Okay, see, for example, whenever you talk about conduction, okay, it will be whatever the temperature from outside to inside, it will pass through some material. Okay, so that is called conduction. Okay, when you talk about convection, which is start from state to state, say for example, when you talk about low temperature liquid to high temperature, right? So or from temperature to gas. Okay, so these are the things we'll talk about convection. Okay, when you talk about radiation, due to this particular heat, okay, when there is a heat, say for example, if you have a gas stove, okay, there is a heat, there is a burner, okay, there is a flame in that, okay, but if you stand nearby, you can absorb the heat, right? So that is called radiation heat. Okay, so this is the basics. Okay, what like a type of heat transfer. Okay, like conduction, convection and radiation. Okay, so this is the basic part, you can able to read in detail. Okay, like you can see here, conduction, convection, radiation and evaporation, right? Okay.
Bhai, can you zoom the sheet because I'm
It's not
using
able
the
to
phone?
visible. Huh? Yeah, okay.
Yeah, yeah, okay, fine, thank you.
I'll be sharing to everyone. This is just we are
Okay,
going through some of the basic documents. Okay. So
okay,
this is the
okay.
basics of air conditioning. Okay. So you can see that there is a dry air, right? So in the dry air, you have a 76 percentage nitrogen, 23 percentage oxygen, and 1 percentage other gases, right? Okay, and you can able to see some of the picture just to understand, because this air conditioning is mainly talk about air properties, right? Okay, so we are purely talk about weather. Okay, so this is the air conditioning system design. Okay, you can see the source of water vapor, right? So the water vapor by means of cooking. Okay, and you can see that wet cloths, right, from the through the rain. So here all you have a latent load. Okay, so whenever you talk about sensible load, it's a dry air. Okay, when you talk about latent load, it is a moisture air. Okay, so that is called sensible load and latent load. Clear, right? Okay, so you can talk about dry bulb temperature. Whenever you are in HVAC, you have to understand what is dry bulb temperature. Okay, dry bulb temperature is the directly indicated by an ordinary thermometer, right? And the wet bulb temperature, you can understand what is the how much moisture in the particular air. Clear, right? Okay, so how you will
Yeah.
find out wet bulb temperature? Say, for example, you have a normal thermometer, you will provide the wet cloth, okay, and you will wait for some time, how much time it take to evaporate. So that the more time it takes, the more temperature will drop. So that is called wet bulb temperature. Okay, by means of that, you can able to understand what is the moisture in that particular year. Okay, if it is not evaporating, that means it cannot able to evaporate, that means the outside air is not able to absorb the evaporation. Okay, so that means what, outside temperature is humidity, more humidity. Clear, right? So that is what it not able to evaporate. Okay, so that is called dew point temperature. When the outside air is 100 percentage, that means the wet bulb temperature and dry bulb temperature is 100 percentage. That means it is that state is called dew point temperature. Okay, and you will see more slides in coming days. Then you have atmospheric pressure, how much pressure in the air, then specific density, right? Specific volume. Okay, how to calculate relative humidity. Okay, you can see the dry air, wet air, right? So dry air is heavier and wet air is lighter. Okay, you can see the hot air is lighter and cold air is heavier. Okay, so these all the things, basic information, it is given in the basics of air conditioning. You can able to read. Okay, try to understand what is specific humidity, what is the enthalpy. Okay, we will talk about more in coming days. Enthalpy is nothing but is a energy, right? How to calculate sensible load, there is an equation. Okay, there is a latent load, how to calculate, there is an equation. Specific heat, sensible heat, latent heat, everything there is equations. Okay, we will we will see in coming days. Okay, whenever when I'm going to calculate latent load, what is the formula I will be using it, right? Okay, then understanding the psychometric chart. Okay, I think most of the people, I'm not sure whether you're using psychometric chart or not, but the psychometric chart is very basic to understand the weather condition. Okay, say for example, if you talk about any of the air, okay, in what condition, okay, you'll be having a mixing uh, conditions like a dry bulb temperature, then you have a wet bulb temperature, then you have a specific humidity, relative humidity. If you go and plot anywhere, you can able to find out all other values. Say for example, this is a psychometric chart. If you know the two values, you can able to find out all other values. Okay, so that we will see what are the values like dry bulb temperature, specific humidity, relative humidity, why it is required, dry bulb temperature, why it is required, specific humidity, why it is required, where you are going to calculate. Okay, and if you go to dew point temperature, why it is required, that all we will see. Okay, specific volume, what is the sensible heat factor, okay, what is enthalpy, why it is required, wet bulb temperature. Okay, and from here you can able to observe. Okay, say for example, if you go to this particular psychometric chart, okay, here you can able to read, okay, dry bulb temperature, and what is the moisture level, okay, and what is the relative humidity lines. Okay, so this is very very important. Even anyone, if you are going for interviews, okay, somebody may ask you to write the draw the psychometric chart, and tell me that where is the dry bulb temperature, how you will measure wet bulb temperature, okay, and specific volume, how you will measure, why it is required. Maybe they used to ask some of the questions. So basically, if you are a HVAC engineer, try to understand the basic concept, right? And how the cycle, refrigeration cycle, okay, and what is the weather properties, okay, like sensible load, what is latent load, okay, and what is the different type of conditions like a dry bulb temperature, wet bulb temperature, specific volume. So this is the basic information you should understand, right? Okay, as a HVAC engineer. Clear, right? So this is the very good guide for you to read whenever you are free. Try to understand each and every information, and then we can discuss if there is any doubt in future. Okay, so this is the basics of applied psychometric charts. Okay, like outside air mixing. Okay, like there is the fresh air. Okay, when we do the fresh air calculations, we will be calculating. We will be using all this chart. Okay, see how to find out each and every condition. Okay, if you go to the psychometric chart, if we try to cool from one condition to another condition, how we are going to cool it. Okay, and when it goes to the return, what is that? So this is like a cycle. You have outside air, when it comes to inside, you have to mixing, then after that it will come to inside the space, then after coil it will reduce that temperature, then after that absorbing the heat, then again it will go back. So this cycle will repeat again and again in the air conditioning process. Okay, so you can understand what is bypass factor. This bypass factor will be using in future. Okay, and what is apparatus dew point temperature. Okay, so these are all the very basic informations. I request you to read one by one so that you people know the basics before you start any calculation. If you do only calculations, maybe you cannot able to understand some of the parameters, right?
Yeah.
Clear, right, everyone? So this particular book is very very good book, and you can able to read this particular information. See, there is a lot of heat, external loads, right? So if you go to this particular here, there are external load, internal load, and other loads. Okay, so the external load, you can see that heat gained by conduction through walls, roofs, windows, right? So whatever the external heat comes through the building, through the walls, everything. So this is called the conduction basically. When somebody is asking what is the conduction, you can say that heat gained by conduction through walls, roofs, windows, and through internal partitions, ceilings, and floors. Okay, then there is a solar heat gain. There is outside air. When outside air comes into the space, then again you have a heat, right? Okay, then you have include internal heats. So internal heat such as like people, lighting, appliances. Okay, then there are other loads such as like leakages. Okay, then you have a motor power or different type of equipments having it heat. Okay, then you have a sensible load component. So the sensible load component will be purely dry. As I told you, sensible load means dry air. Latent load means moisture air. So when you talk about sensible load, so the lighting will come in sensible, right? When you talk about people, the people have both sensible and latent. Okay, okay. When you talk about when you talk about when you talk about latent load, you can see that say for example cooking appliances, you have a latent load and sensible load. right? So these are the parameters to understand. Okay, then you can see that inside when you do the calculation part, okay, there are different type of heats. So you are going to identify, okay. Okay, so this is the procedure for the manual method, but as of now, no one is using the manual method. We have a HAP software which is approved by local authority, right? Okay, so this is the direction. Okay, when you say, whenever you do the calculations, you should understand the directions part. We will see there is a step, there is another guideline for how to do the HAP calculation. What are the equations that we will see in the coming classes, right? Okay, so the heat from the people, how much sensible, how much latent. Okay, okay, so this is the air distribution part. This we will talk about duct sizing calculation. We will talk about in detail. Okay, then there is air diffusers, right? So how to mount and what is the type of fans, duct design, how to do the duct design. Okay, so this particular basics of guidelines, if somebody, whenever there is a time, if you try to read this information, you can able to understand. See, there are different type of methods to calculate your uh, duct sizing. There is a equal friction method, velocity reduction method, static regain method. The most familiar will be equal friction method because the fan performance will be better, right? And what is the velocity you have to maintain, recommended duct velocities in different areas. Okay, I think this is the concluding part. So whatever we have learned, like introduction of human comfort, air conditioning, properties of the air, understanding psychometrics, applied psychometrics, estimation of cooling load, air distribution part, duct designing. So these are the things you can able to understand. But from here, the basics of air conditioning guideline. Clear, right, everyone? Okay, so whenever you have a time, just read that one. It's a lot of informations, but if you try to read slow by slow, you can able to do it in better way. Clear, right, everyone?